Students, this is lesson U4A07c. By the end of the lesson, you should be able to say, I can use properties of sides, angles, and diagonals to identify a kite or a trapezoid in a geometric proof. Alright, so let's take a look. I encourage you to copy down the diagram as well as the given information in a statement and reason chart like I have here, and then press play again once you have attempted it. So hopefully you guys had some time to think about this. What we want to do is we want to demonstrate that this is in fact a kite. As you recall, one of the ways in which we can show that the quadrilateral is a kite is to show that we have two pairs of adjacent sides, or we can have we can have two pairs of congruent adjacent sides. What am I saying? Another way to show that a quadrilateral is in fact a kite is to show that the diagonals, one of the diagonal is the perpendicular bisector of the other. But looking at this upon close inspection, I already see that probably showing that we have two pairs of adjacent sides will probably be the way to go. I know that ABE is congruent to CBE, and using another color now, I know that ADE, which is in blue, is going to be congruent to CDE, which is this guy right here. So the two triangles in pink are congruent, the two triangles in blue are congruent. I can then say, using CPCTC, therefore that AB is congruent to BC and AD is congruent to DC, and there you have it. That's the end of the proof. Let's put this all into words. I know that AB is congruent to CB because of CPCTC. I also know that AD is congruent to CD because of CPCTC. My fifth and final statement, therefore, ABCD is a kite because I have two adjacent pairs of sides are congruent. Let's take a look at another example. I want to show that ABCD is an isosceles trapezoid. Pause the video to see if you can figure this out. Please create a statement and reason chart like I have here, and then press play to resume. So hopefully you guys had some time to think about this. Triangle ABE is congruent to triangle DCE, which is congruent to triangle BEC. So looking at this, all three triangles are actually the same length, or actually all congruent. So because they're all congruent, and I know that AD is a straight line, so why would quadrilateral ABCD be isosceles as a result of this? Well, if I look closely here, I know that AB, right, corresponds with CD. These two sides are going to be congruent. I also recognize that what I have is this angle is going to be congruent to this angle here. Well, that's because of, again, CPCTC. However, we can also then therefore conclude that BC is going to be parallel to AD. And that pretty much will be the end of the proof, because if I can show that BC is parallel to AD, then therefore we have one pair of parallel sides. We also have one pair of congruent sides. And that will be enough to demonstrate that it's an isosceles trapezoid. So let's put this all into words. So I know that AB is going to be congruent to CD or DC, and this is because of CPCTC. I also recognize that CBE is going to be congruent to AEB because of, one more time, CPCTC. The next conclusion is I know that BC is going to be parallel to AD because these are alternate interior angles. Notice I used the word converse here. It is not necessary that you actually write the word converse, but if you do, it's just saying that, we're going in reverse, but you don't have to have that word there. And then line number 6, we can then conclude that ABCD is in fact a isosceles trapezoid because one pair of parallel sides and one pair of congruent sides is present.